What is up, guys? It's Mr. Chap, and today what we're going to do is we're going to write a cheat sheet for atomic structure. So we started studying chemistry. You guys need to know all the different subatomic particles, their charges, their locations, etc., their masses. You also started learning about how to read a periodic table. So we're going to, instead of doing a foldable like you would in your INB, over this stuff, I want you to have a cheat sheet that you can use on assignments and that you can use on quizzes and tests, right? So that's what I'm going to title this. I'm going to start at the top. I'm going to write atoms cheat sheet. Keep this, don't lose it. It'll make your life a lot easier. Okay, so first on the very top, we're going to talk about the 3 subatomic particles that we have and all the information about them. We watched a video going over a lot of this, but you didn't copy it down, so now you are. So our 3 subatomic particles are protons, neutrons, and electrons. I'm going to try to go through this quickly. If you can keep up with it, that's great. If you need to pause to catch up, that's great too. Right. Okay, so I'm going to draw a line under all of it, a line down, make it shorter so that if we need to, we can add more to the line. Okay, so first let's talk about the charges. Protons, neutrons, electrons, they all have different charges. And so I'm going to write charge over here. And protons are positive, that they both start with a P, proton, positive. Neutrons are neutral, meaning they have no charge. And electrons are negative. So protons are positive, that starts with a P. Neutrons are neutral, neutron, neutral, meaning they have no charge. Electrons are negative. The flow of electrons, the movement of electrons is called electricity, and if you touch electricity, it's not going to feel good, and that is a negative feeling. All right, so the symbol for these charges, at least, is for positive, I'm going to use a plus. For neutral, means no charge, I'm going to use a 0. But when you're drawing a model of an atom, that just looks like a circle. So you want to put a slash through it like that. And then for electrons, they're negative. Often I'll also use the first letter of each, the first letter of each here. So I'll have P plus, N0, and E minus. So they also have different masses. This has a mass of 1 AMU, atomic mass unit. You can think of that kind of like a gram or a kilogram. It's a unit of mass. This is 1 AMU. Protons are 1 AMU. Neutrons are also 1 AMU. They have about the same mass. Electrons are very, 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 very small, and so they have 1/2000th of an AMU. So they're very small. 2,000 of electrons. It would take 2,000 electrons to equal one of these. Lastly, we're going to talk about location. So let's write location over here. And protons are inside the nucleus, which is in the middle. Neutrons are also inside the nucleus. Electrons are located around it. You might want to say that they orbit the nucleus, and they're located in what's called the electron, or E minus cloud. that's that area where they're all kind of swirling around all over the place, and they're going so fast that it looks fuzzy like a cloud. All right. So this is your cheat sheet for the different subatomic particles. Now we're going to kind of label out what all the parts of a periodic table tile mean or look like. All right. So first, we're going to draw a box over here, and we're going to draw a sample tile. The periodic table, where you're going to get when you go to pick up your Chromebook, if you do that, or if you come up here, or you can print one off, you're going to get something that looks like this. This is the periodic table. This is the 8th grade science star periodic table. If you pick it up from me, it's going to have that, and then on the other side, it's also going to have the physics formulas that you'll need. So make sure you keep this. But we're going to go with this one right here. You're going to write a 14 on top, a big S, we're doing sulfur, a 28.085 right there, and this is silicone, for silicone. So this top number right here is atomic number. Oh, I don't know why I added an E there. Number. This big letter is called the symbol, or element symbol. This number right here, this bigger number with the decimal, is called the atomic mass. And then this down here is just the element name. Alright, so the reason I put this, I had you guys write this, even though it is on here, is you're going to have to start doing calculations to figure out three things. We have 3 subatomic particles, and you can use this table, or this tile on the periodic table on any of these to figure out how many protons, neutrons, and electrons we have. And the way we do this is something called APE MAN. So in this area right here, that's what we're going to do. Alright, so we're going to write APE MAN, A-P-E-M-A-N. Okay, so let's start. These are 2 different acronyms that will help us figure out how many protons, neutrons, and electrons this has. Let's start with APE. So you're going to write A equals P equals E. APE. And that means the A stands for this A right here. If you want, you can underline it. A. This means that the atomic number equals the number of protons equals the number of electrons. Yeah. Alright, so that means that if I know my atomic number, which is given right up here, I know the number of protons and the number of electrons for this atom. So, sulfur, actually we'll go over that in a little bit. Alright, but, so now you know protons and electrons. Protons and electrons, you need to figure out neutrons. And to figure out neutrons, you use MAN. MAN stands for, here you go, right, M minus A equals N. That stands for mass, which is right here, right there, minus the same A, atomic number, equals the number of neutrons. Mass minus atomic number equals number of neutrons. Okay, so that also, another way that I told you to remember mass is the number of protons plus the number of neutrons, same thing. All right, so we are going to calculate underneath here, just as an example, we're going to calculate the protons, electrons, and neutrons of sulfur. So I'm going to write sulfur over here so you know that this isn't just some random math. And first I'm going to copy down this formula, A equals P equals E. P equals E. And my A is my atomic number, so I'm going to go over here. My atomic number is right there, so I'm going to write 14 equals 14 equals 14. So the three things that I'm looking for right now are P, protons, E, electrons, and neutrons. So now I know that I have my protons right there, it's 14. And I know that I have my electrons right there, it's also 14. I'm looking for my neutrons, so I have to use man. For man, I'm going to write M minus A equals N. And my M, it's my mass. Remember, we round that. So you're going to look at that decimal point. If that if this number is 4 or less, it's going to be it's just going to round down to 28. If it's 5 or more, add 1 more, and that would go up to 29. So you're going to look at that. It's going to be a 0, so that means it does not go up. So you just get rid of that, and your atomic mass you're going to use is 28. So I'm going to write 28 minus, and then you're going to use the same A, 14, your atomic number, equals 14. So now you have your N. So an atom of sulfur has 14 protons, 14 electrons, 14 neutrons. The neutrons are not always going to equal the other two, but often it does. But so don't just calculate. Don't just assume. You need to calculate it out using APE MAN. All right. One last thing over here. I'm just going to write rounding. You're going to say 5 or more. Let's see, 5 or more. Add 1 more. There you go. 5 or more, add 1 more. So you can look at the number after the decimal. If it's 5 or more, you add 1. If not, you just let it go. Alright. Make sure that you keep this, take a picture of it, upload it for the assignment, but keep it handy, tape it on your wall if you need to. It will come in very handy on our assignments. We're going to be working on chemistry for the next 8 weeks, so this will be very helpful. Don't lose it. Don't if you're going to clean during winter break, don't get rid of it. It will be very handy. All right, I'll see you guys in class. Bye.